Here is another second derivative test example. Determine the relative extrema of this function using the second derivative test where possible. So again, to use the second derivative test, we have to find the critical numbers. And that's where the first derivative equals 0. So the first derivative is 4x cubed minus 12x squared. Set that equal to 0. Factor to get the zeros. And we find the critical numbers are x equals 0 and x equals 3. Now, to use the second derivative test, we will find the second derivative. So look at the unsimplified first derivative, it will be easier. That derivative would be 12x squared minus 24x. And I'm going to factor that to make my calculations a little bit easier. So that's what we have. So now the second derivative test we'll do right here is you just take these critical numbers and plug them into this second derivative. So the second derivative at 0, you can see is going to be 12 times 0, which is 0, times the negative 2, which is 0. Now that means you can't use the second derivative test. This is not positive or negative. So when the second derivative equals 0 at a critical number, you have to go back and use the first derivative test, that chart. And we'll do that in a second. But let's test the other critical number, x equals 3. So the derivative at 3 would be a positive times 3 minus 2 is a positive 1. So a positive times a positive. So the second derivative is positive at 3. So we have a minimum at x equals 3. And then we plug this into the original function. 3 to the fourth is 81. 3 to the third is 27, and 4 times 27 is 108. And 81 minus 108 is 27, negative 27. So we have our minimum. Now going back to f prime of 0, or f double prime of 0, that was inconclusive because it wasn't positive or negative. So when it says go back and use the first derivative test, we're going to concentrate on our first derivative, which was 4x squared equals 4x squared times x minus 3. And now use the chart with the critical numbers. So our critical numbers are still 0 and 3. We're not sure what happens here. We know that this is our minimum. So our first derivative here, we don't have to worry about it. We already found it. So just between 0 and 3. So f prime of, that's a single prime. This is what we did before in section 3.3. F prime of, say, -1 in this interval f prime of, say, 1 in this interval. If you plug it into the first derivative, when you plug in -1, you'll get a positive times a negative, which is negative, which means it's decreasing. And when you plug in 1, you'll get a positive times a negative again, which is decreasing. So since the first derivative went from decreasing to decreasing, 0 is not a minimum or a maximum. So 0 is not a relative extrema. So the only extrema we have is right here. And that's it. You should type this on your calculator, the original function on your calculator, or on Desmos or some other kind of graphing software, and you'll see that these answers are correct.